to see. It is very important topic. But there are so many formulas in trigonometry. Today we are going to discuss some formulae from the trigonometry, general trigonometry. So student, remember one formula like this: sine of p minus sine square of p minus sine square of q. Sine square of p minus sine square of q असेल तर आन्सर ट्रिग्नोमेट्रिक फॉर्म्युला आहे sin of p plus q sin of p minus q. Remember this is very important formula. So if you have in any problem sin square a minus sin square b, then answer is sin square of a plus b sin of a plus b sin of a minus b. As like that, sin square of b minus sin square c असेल, if there, the answer is sin of b plus c sin of b minus c. Sorry. In this way, if there is term sin square of c minus sin square of a, answer will be sin of c plus a sin of c minus a. So these are the formulae from trigonometry or general trigonometry. Student, remember these formulae are from general trigonometry. Our this trigonometric functions topic and these formulae not related to each other. These are from the general trigonometry. But these are useful in problem solving of our trigonometric function. So remember. So in today we are going to solve some problems from exercise 3.2. We are going to solve exercise 3.2. There are some problems which are useful. So see, very first, prove that with usual notations in triangle ABC, prove that sine of b minus c upon 2 equal to b minus c upon 2 cos of a by 2. You have to write proof for this relation. You have to write proof for this relation. So see, by Napier's formula, as like Napier's formula, if we had completed Napier's formula in previous lecture. So remember, as like Napier's formula, we are going to solve this. So as like Napier's formula, we are going to solve this. Okay? So consider b minus c upon 2 or a. I think there is a. So what happened? See, k sin b minus k sin c upon k sin a. After that, see, it will be b minus c upon a equal to sin b minus sin c upon sin a. So now transfer this a sin a to LHS. Then it becomes b minus c upon a sin of a equal to sin b minus sin c. Remember. So after this step, equal to 2 times CD formula is to use. 2 times cos of B minus C upon 2 sin of B plus C upon 2. B plus C upon 2. But now see here, if here is B plus C, then we can convert it in terms of A. Use B plus C is pi minus A. That is sine of, it become pi minus A means pi by 2 minus A by 2. It means cos of A by 2. So that part converted in terms of A. Converted in terms of A. Therefore, B minus C upon A sin of A equal to 2 times cos of B minus C upon 2 into see now sine means cos of A by 2, cos of A by 2. But now see again see what happened. See this part B minus C upon A, 2 times sin A by 2 cos A by 2, half angle formula is used. 2 times cos of B minus C upon 2 cos of A by 2. Cos of A by 2 and this cos of A by 2 cancel. So that what is the answer? And 2 also cancel. Therefore, we get here cos of B minus C upon 2 equal to B minus C upon A sin of A by 2. Proof is completed. So remember student, this is the correct problem. So this is the correct problem. Okay, next. Next problem is to see here. See now, you have given question is prove that 2 times in bracket A sin square C by 2 plus C sin square A by 2 equal to A plus B plus C. So, student, answer is to obtain A plus B plus C of LHS. So, consider LHS. Consider LHS. LHS is equal to this part. So it is equal to A into 2 times sin square C by 2 plus C into 2 times sin square A by 2. So it is equal to A into answer of this part 2 times sin square theta by 2 means 1 minus cos theta means 1 minus cos C plus C in bracket 1 minus cos A, and now multiply by A. So A minus A cos C plus C minus C cos A. Again, A plus C minus sign if we take common, A cos C plus C cos A. But by projection formula, this part is nothing but this A and C is there. Therefore, remaining symbol is, side symbol is B. Therefore, LHS is equal to A plus C minus B. LHS is equal to A plus C minus B, which is RHS. And proof is completed. So important steps are here. Conversion in 2 times sin square C by 2, 2 times sin square A by 2. After that use 2 times sin square theta by 2 means 1 minus cos theta. Therefore here is 1 minus cos A. Therefore here is 1 minus cos A. After that multiply by A, multiply by C. A minus A cos C. C minus C cos A. A and C get together. And minus sign taken common from these two terms. So in bracket A cos C plus C cos A by projection rule, its answer is B. And that written there, answer completed. So student, remember, it is this problem depend upon trigonometric formula as well as projection formula. Now see next. See next problem. Show that A square sine of B minus C plus B square sine of C minus A plus C square sine of A minus B. Answer 0. Just these problems are depend upon calculations. Simple problems are there. So to write proof of this problem, see, terms are similar. Terms and terms. 3 terms are in LHS. So we are going to find in proof. One by one, each term we are going to find. So very first, A square sine of B minus C is K square sine square A in bracket sine B cos C minus sin C cos B means K square sin square A sin square A sin B cos C minus K square sin square A sin C cos B. Similarly, second term, B square sine of C minus A, K square sine square C, sine of C cos of A minus sine of A cos of C. Multiply. Here will be. So k square sin square B. Sin C cos A minus k square sin square B sin C sin A cos C. Second term is completed. After that, third term, c square sin square A minus C, k square sin square C, A minus B, sorry. So sin A cos B minus sin B cos A. So multiplication, k square sin square C sin A cos B minus k square sin square C sin B cos A. And after this, addition of these three terms, sin square A, see, sin A. See, here is not square, here is only ABC. So not square. Squares are not there. Remember. No any square term is there in problem also. And after that, see ABC minus ABC. Cancel. ACB, ACB. Cancel. So in this way, that terms are cancelled and total answer is 0. In this way, this problem is also here completed. So in the next, see now next problem. Show that chord A, chord B, chord C are in AP when A square, B square, C square are in AP. Arithmetic progression. What is meaning of arithmetic progression? See here, arithmetic progression means if alpha, beta, gamma are in AP, it means beta minus alpha equal to gamma minus beta. Difference of two successive terms is same. Difference of two successive terms is same. It means that three terms are in arithmetic progression, are in AP. So A square, B square, C square are in AP are given. It means B square minus A square equal to C square minus B square. It means K square sin square B minus K square sin square A equal to K square sin square C minus K square sin square B. K square cancel, sin square B minus sin square A equal to sin square C minus sin square B. But just in starting of our lecture, we discussed the formula about this. So, by trigonometry, sin of B minus C, sin of B plus C, sorry, B minus A, B plus A, because sin square B minus sin square A is equal to sin of C minus B and sin of C plus B. But after that, this part is pi minus C, and therefore this total part is sin of C. Similarly, this part is pi minus A. B plus C means pi minus A. Means this total part is sin of A. Sin of A. Therefore, sin C into sin of B minus A. Sin C into sin of B minus A is equal to sin A into sin of C minus B. After that, sin C into sin B see now, we convert it in the form of ratio for our simplification convenience. So, sin of B minus A upon sin A is equal to sin of C minus B upon sin C. So, sin B cos A minus sin A cos B upon sin A equal to see now sin C cos B minus sin B cos C upon sin C, so that sin B into cos upon sin A means cot of A minus sin A cancel cos B is equal to sin C cancel cos B minus sin B cos upon sin cot of C. Now divide each term by sin B. Therefore, cot of A minus cot of B equal to cot of B minus cot of C, and do sign change. Therefore, cot B minus cot A equal to cot C minus cot B, and it means cot A, cot B, cot C are in AP. Is proved. Are in AP. So proof is here completed. Proof is here completed. So remember, in this way you have to complete this proof. Now see one more example. Last example now. I think this example, last example, is related to the yes formula because half angles are appear therefore. Prove that or show that sine A by 2 into sine B by 2 into sine C by 2 equal to area of triangle ABC square upon ABCS. S means semi-perimeter. So consider LHS. Simple problem is all are half angles, so use half angle formula in terms of LHS. Under root S minus B, S minus C upon BC. Under root S minus A, S minus C upon AC. Under root S minus A, S minus B upon AB. S minus A, S minus A, S minus A square, square root. S minus C, S minus C square, square root eliminated. S minus B, S minus B square, square root eliminated. So terms are here S minus A, S minus B, S minus C upon B into B, B square, C into C, C square, A into A square, square root eliminated. ABC. Adjustment of S. And this is square. Now, this part is square of under root S into S minus A, S minus B, S minus C upon ABCS. But this root is nothing but it is by the Heron's formula, it is area of triangle, and therefore it is area of triangle ABC bracket square upon ABCS, and which is RHS. So it is completed. So remember, student, in this way you have to solve this exercise also. So from tomorrow's lecture now we are going to see next part of this trigonometry functions topic, and that is about inverse trigonometry. So student, thank you. Today's lecture is over.